we are going to be going over page 24. So I'm going to give you some time to be working on that. These apply problems relate to the apply problems that we did yesterday. So if you need to refer back to pages 21 and 22, you can definitely do so. Remember, we did two different checks. We did the check and an extra example, so we should work for both of those. So not only do we need to be able to use the product of powers rule and the quotient of powers rule, we need to be able to apply that, right? We need to be able to use it in real life situations. How does that help us? So I think this is probably the most important part of our practices is the apply section. So we have 10 through 15 that we're completing today independently right now. So we're at a level 0. I'm going to give you some time. Make sure you're referring back to your notes and examples, and then we'll go over it in just a few minutes. Okay, so number 10. Come back to me, number 10. We're all on page 24 in our packet. Your Chromebook should not be out right now, especially if you were not done with page 24. All right, apply. Foster's Farms has 5 to the 3rd fruit trees on their land. Myrna's Farms has 5 times as many fruit trees as Foster's. So what are we multiplying the 5 to the 3 by? Well, it says 5 times as many, so we're multiplying it by 5. So this Myrna's, I'm just going to write M there, is this 5 to the 3 times 5. How would I write that as an exponent? 5 to what power? 3 plus 1. It has 5 times as many fruit trees. So we're taking what it is now and multiplying it by 5. So we have 5 to the 4th power. Now, a commercial farm has 500 fruit trees. Which one has the most? So the commercial farm, my friends, when I'm talking, you are not. The commercial farm has 500. So if we had our calculators, we can use them, right? 5 to what power? I'm going to use the caret power. If I'm figuring out Foster's, it's 5 to the 3rd power. So this was equal to 125. One you should definitely know and remember, right? We know that one wasn't going to be the most because the Myrna's have 5 times more. So if I multiply that by 5, we get 625. So which farm has the most? Myrna's has the most. All right. The table shows the number of bacteria in each petri dish. Dish C, there's another dish, has 8 squared, has 8 squared times as many bacteria as dish A. So this is 8 to the 6 times 8 squared, which is 8 to what power? The 8. Which petri dish holds the most? D. 8 to the 9th is greater than 8 to the 8th is greater than 8 to the 6th, right? All right. Number 12. Write a multiplication expression with a product of 8 to the 13th power. So how many times do I have the factor of 8? 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that would work, right? No, that would be so cheap. Or you could say 64 times 64 times 64 times 64 times 64 times 64 times 8.
Or 8 to the 13th.
Oh yeah, or 8 to the
Times 1.
13th power times 1.
That's so silly.
Yep, you could say 8 to the 7th times 8 to the 6. Yep, you can add them, right? 8 squared
It's just
times
multiplication expression. Yeah.
to the 8
You can't add, it's multiplication.
times 8 to the 3rd. Remember, we're adding those exponents. You can do it in anything like that. So lots of different multiplication expressions. However, you're right, this would be a pop multiplication. Power expression. Same with 8 to the 13. If it includes the pop. We want to get really technical. All right. What is 4? Let's write it out. What is 4 times 4 to the 15th power? These bases, are they the same? Yes, so we just add the exponents. What's my exponent of this 4? 1. What's 1 plus 15? 16. Is that what you got?
I did it wrong.
Hopefully you see your issue if you did do it wrong. All right, this gets a little tricky. Consider the sequence below. The number 4096 belongs to this sequence. What is the number that comes before it? Well, what are they doing to get the next number? They're timesing it by 2 each time. So to go the other way, to find the number that precedes it, what do we have to do to this number? Divide it by 2. So to go back the other way, we have to divide by 2. So the number that proceeds, not proceeds, that precedes 4096 would be divided by 2. So what'd you get? 2048? Is that what it is? Okay. All right, this one got a lot of you. So I'm gonna give you just a couple more minutes. I want you to think about this.
Then you go 5.
How many factors of 4 do we need to multiply to get this?
5.
So if you are using your calculator, listen. 4 times 4, that's 2, times another 4 is 3, times another 4 is 4, times another 4 is 5, times another 4 is 6, times another 4 is 7. So 4 to the 7 equals 16,384. So if you figure that out, how do I figure out what n equals?
Could you subtract the exponent?
Yes, so 7 minus 2 is
Off.
5. So n equals 5. Or you could have divided this by 16. So you could have said divided by 16 equals. So 4 to the n has to equal 1024. And then you could have multiplied by 4 or divided by 4 to see how many times, right, Anders? Yeah, let's focus here, guys. All right, we are gonna go ahead and start our lesson 1-3. We're just gonna kind of explore today. So remember, when you're not here, you can always hop on Zoom. You may also watch the recorded, like right now we're recording, so it's helpful if you are doing your best to stay quiet. Remember, when you log into Clever, you click on the red McGraw-Hill app. That's how we get into Alex. So we're spending at least 10 minutes a day in Alex, and then we're working in our reveal math. So when we open the calendar today, I haven't actually put anything in the calendar. I wasn't sure we were gonna get here, but I'm so happy that we get to start this today.
Or we can like.
So we are going to add this presentation to our calendar. And we're gonna start it today, which means I'm hoping to finish it on Monday. We'll see. Oops, not gonna be, that was silly. I have to go to October. Monday is October already. So now, when you go to the dashboard, Jace, Anders, I need it to stop. AJ, boys, lots of boys chatting. Thank you, girls. We're not chatting right now. That's what it is. All right, so we are looking at our calendar. We can click on powers of monomials and view that here. All right, so let's launch this presentation. We're on page 25 in your packet. This is telling you, gentlemen, this is telling you that there's an explore thing in our, on an online activity. You don't have to go there right now. I'm just showing it. We're doing it together. Okay, so murals are pieces of artwork that are painted or applied to a permanent surface like a wall or ceiling. Murals are usually very large, with one of the largest covering more than 225,000 square feet. That's pretty large. A mural, listen, at a local school is in the shape of a square and has the side lengths of 5 to the x cubed. What does the expression 5x cubed all raised to the second power represent? Do you think it is equivalent to whatever is in that factor times itself? So do you see what's in the parentheses there? We would call this whole thing the factor. And how many of those factors do we have? 2. So we would write it out to be multiplied. So we should say, yes, it does. So today we're going to change standards. Hopefully we can already use the laws of exponents to multiply and divide monomials with common bases, because we are done with 1, 2. 1, 3 tells us we have to know and apply the properties of integer exponents to generate equivalent numerical expressions. So our new I can statement is I can use, we have a new law, the power of a, or property rather, the power of a power property and the power of a product property to simplify expressions with integer exponents. So we're not going to have algebraic exponents yet. Our exponents are still going to be numbered. Numbers. How can we use these? This is the important part. Why do I need to know this? We have to be able to extend our understanding of the product of powers to work with powers of products and powers of powers. And we need to study the structure of an expression to identify it as a power of a power or a power of a product. So what vocab, these vocabulary are on the top right. Power of a power property. What do you think power of a power is? What do you think? So some power raised to a power. So just like we just saw, we had an exponent, and in parentheses, there was another exponent. So see how the powers were right next to each other, TJ? Power of a product property. Our powers are being multiplied. Our powers are We're not sure what we're gonna do with these yet, are we? All right, here's our explore. We're gonna explore power of a power first today. So we're trying to figure out how we can simplify a power raised to another power. Welcome. When I'm talking, you are not. That is the expectation. The Marine Club at Westview Middle School purchased an aquarium. The aquarium is in the shape of a cube with a side length of 2 to the 4th power. Watch the animation to see how you can determine the volume of the aquarium.
An aquarium in the shape of a cube. Each side of the aquarium has a length of 2 to the 4th inches. The students want to know how much water the aquarium will hold. To determine this, they will need to calculate its volume. In the formula, V represents the volume, and S represents the length of one side of the cube. Since the side of the aquarium has a length of 2 to the 4th inches, let's substitute this value for S in the formula. The formula now has a power, 2 to the 4th, raised to another power, the 3rd. How do we simplify this expression?
All right, how would we simplify that? Any ideas? No? Right, 2 to the 4th power 3 times. So 2 to the 4th is now becoming our factor. So we would write it out this many times, whatever our exponent tells us. Good. So the volume of the aquarium can be represented by this. So that 2 to the 4th becomes our what in this expression? Our new base, right? That's our factor. What does the exponent tell you about the base in the expression? We just said it. That's how many times we are writing our base, right? That's how many times we have 2 to the 4th as a factor. Nice job, Noah. So the expression 2 to the 4th to the 3rd power, written in that expanded form, is 2 to the 4th times 2 to the 4th times 2 to the 4th. So we can simplify this using our product of powers rule. What would we do? We would say 4 plus 4 plus 4. What is repetitive addition? What's repetitive addition?
Isn't that where like you have more than one?
Multiplication is repetitive addition.
That's the same thing.
Yep. So it means, so we could say 4 plus 4 plus 4, or we could simply say 4 times. How many times are we adding 4? 3 times, right? So 2 different ways.
24.
So compare the exponents. How did they get 12 from 4 and 3? Let's go leave it there then. How did they get the exponent of 12 from the 4 and the 3? What did they do, Logan? Excellent. They multiplied them. Is 4 times 3 12?
Yeah.
Do you see what our power of a power is going to be?
Yeah.
Hopefully. So how can we simplify a power raised to another power? What can we do with the exponents? Multiply them. It's gonna multiply them.
Yeah.
Yay, yay, multiply them. All right, so the following expressions are represented in expanded form. So see how they wrote out that factor that many times. So if we used our product of powers, we would be adding them. And we know repetitive addition is multiplication. So instead, we're going to be multiplying them to keep them easier. So how can we simplify a power raised to another power? We multiply the exponents. We're going to multiply the exponents. So right on the top of your page, right below this, you'll explore how to simplify a power raised to a power. We're going to write, we are going to multiply the exponents. That way, we'll already have a head start tomorrow when we come in. Okay? So be sure you are including that in your notes so that we're ready to go tomorrow.